Good morning to all my colleagues and so on. So here we are presenting the topic on optimizing industrial geometrical energy solution using a hesitant bipolar fuzzy MCDM approach enhanced by Dombi operators. In this, we have context. Firstly, use some we use the Dombi operators. Secondly, preliminaries. What is the previous? And the third is the literature review. And the fourth one is objectives and results and outcomes. And last one is the references where we used from all this. From introductions, we have used some like this classical sets where the crisp set, a set is a well-defined collection of distinct objects or elements, and what is the difference between a logic classical set theory and fuzzy set theory. Introduction. Fuzzy logic. Chede introduced the concept of fuzzy set theory. In fuzzy logic, the membership of an element is a set, is not a binary, but rather than a matter of degree. Either it is zero point 0.1, 0.2, and so on. Fuzzy sets allow for partial memberships, where an element can belong to a set to a certain degree, rather than being strictly in or out. The degree of membership is quantified by membership function, which assigns a value between 0 and 1 to each element in the universal set. For example, the concept of tall people can be presented using crisp logic because the notion of tallness is subjective. Fuzzy set theory allows us to represent this by defining a membership function. This assigns higher values to the taller people and the lower values to the shorter people without a sharp cutoff. Introduction, intuitive fuzzy sets. Now from the fuzzy sets, we have move on to the intuitive fuzzy sets. The intuitive fuzzy sets is developed by Aksanov, the concept of intuitive fuzzy sets, where we introduce with the membership and the non-membership. If the no in the non-membership, the participants or the set element belong to the set or the node. The membership degree and the non-membership degree of an element in an intuitive fuzzy sets are such that their sum is less than or equal to 1. The hesitancy degree. Now we have defined the hesitancy degree is defined as the difference between 1 and the sum of membership and the non-membership degree. If the sum of the membership and the non-membership degree is like 0.8, then the hesitancy is this 0.2, where the people is to hesitate to the set, the element, the proper element is partially belong to the set or not to the set. This is the hesitant degree we used in our MCDM technique. Next, consider a scenario in a customer satisfaction survey where responses are asked whether they are satisfied with the product. In this context, the responses can be classified into three categories: satisfied membership, non-satisfied, and unsure, where hesitancy is the unsure. Like this scenario can be captured in an intuitive fuzzy set by assigning a degree of membership to satisfaction, a degree of non-membership to the dissatisfaction, and a degree of hesitancy to reflect their uncertainty. Now we have moved in the optimization. Why used in the optimization here? Due to the close relation with real world scenarios, fuzzy and intuitive fuzzy set theory have been extensively applied to mathematical programming problems. Mathematical programming is an important part of operations research. Some widely studied mathematical programming problems are linear programming problems, non-linear programming problems, quadratic programming problem, and so on. Now, fuzzy logic addresses these challenges by incorporating uncertainty into parameters, variables, or constraints as specified by the decision maker. The membership, non-membership functions can take various forms such as triangular, trapezoidal, or Gaussian depending upon the specific requirement of the problem. Now we have moved with the definitions. Firstly, we define what is the intuitive fuzzy set. Where the intuitive fuzzy set, let X be a fixed and intuitive fuzzy set A bar defined like this. In definition 2, we define a trapezoidal intuitive fuzzy set where we use the membership with the mu and the non-membership with the V. Mu of this is the now is the graph membership and non-membership function of this. These represent the red line here represents the non-membership and the green line represents the membership. Now we have continued with the definitions part. We firstly move with the review. Fuzzy and inductive fuzzy sets have found extensive applications in numerous optimization problems. However, the study on fuzzy and inductive fuzzy theory is restricted to the class of linear programming. Here we use the hesitancy bipolar fuzzy sets. In the bipolar fuzzy sets, we further move to the multi-criteria decision makings, where the research objectives to study inductive fuzzy quadratic programming problems using this to develop a normal efficient solution methodology for inductive fuzzy quadratic problems to reduce a motivation to gamma operator, where is the Dombi operator, we can say, technique for solving inductive fuzzy multi-objective non-linear programming problems, where in this manuscript we used a geothermal plant to ensure multi-criteria decision making problems based on Q-rung ortho pair numbers. Here, the proposed inductive fuzzy quadratic programming problem. We propose to formulate and model with constraints of lower and upper bound, which can be modeled as follows. For the maximize to this and subject to these constraints, where AK, BK, CK are the inductive fuzzy numbers and the matrix is a negative semi-definite, making the given problems a convex optimization problem. We propose to establish all new cuts in order to retain the inductive fuzzy set of the problem. In this definition, there would be two lower and two upper bounds in connection with the membership as well as non-membership functions. In this, here we will discuss the sub-model related to membership functions by applying on the objective function, and the constraints in the process model is obtained from the model and is this as follows. Maximize the objective function subject to the constraints, which is the given in this, where we have like MCDM problem. If we further move to the application part, where use the duality approach, proposed alternate method for the lower bound corresponding to the membership function. We now propose an alternate method to determine the lower bound. We have to find the lower bound of the constraints of the problem one, which is more efficient than the duality approach. In the optimization, we use the simplex method, duality approach, but we proposed the alternate method. Both the duality approach and the alternate method result in the same objective function value, where we have to maximize the profit and minimize the cost. And however, the revised formulation requires fewer variables and constraints than the model 9. Now we assert the new formalization to obtain lower bound is as follows, where Z is the constraint maximized and subject to these constraints. To support our assertion, we will prove that the dual of program is identical to leading the same optimal value. Now, proposed alternate method. The model, there's the model 10 can be equally written as, we have to this is the model 10, and we have equally written as Z maximized subject to these constraints. Proposed alternate method. Now let these are the Lagrange's multiplier associated with the constraints of the above problem. These are the Lagrange's multiplier. So we have to find the constraints with the conditions we have used in that specific sequence, that the dual of the program can be expressed as follows, where we have to minimize and maximize. Firstly, we use in this program, we have to use minimize. We change the duality, maximize converted to minimize, and here minimize the equation. And the equation is given by this proposed alternate method. And these are the further explanations of the method. Now we move to the publications part. Here this. Now applying this beta cut, the objective function and on the constraints, we get model as follows. Maximize. Now we have to case study. We have to based on the case study. Here, this is the MCDM technique, hesitant bipolar fuzzy MCDM technique. In this part, we suggest a MCDM strategy in the context of hesitant bipolar fuzzy numbers. Based on suggested operators, we have to define, let us assume that there are alternatives and criteria along with criteria weights. Now we assume that the hesitant bipolar fuzzy decision matrix is this. Next, we have the following algorithm steps in our MCDM technique. The step 1, convert cost type attribute to benefit type. We have to minimize the cost and maximize the profit. Convert cost type attribute to the benefit type. Step 2, utilizing arithmetic and geometric operator based on the hazard and fuzzy set. And the step 3, determine the score values. What is the score values? Rank all the alternatives and choose the fifth step is choose the best alternative. Now step 1, a benefit type and a cost type are two possible attribute types in MADM process. If an attribute is provided in the form of cost type, then we convert it to benefit using the formula. This for the benefit type of attribute and the for cost type of attribute, we consider the complement. Now in the step 2, by using the operators, arithmetic operators and alternative operators, these are the arithmetic operator for the hesitant bipolar fuzzy set and the in equation 16, and then equation 17 we use the geometric operator. And step 3, compute the score values by utilizing the above formula in the fundamental section. Step 4 is rank all the alternatives and choose the best. Here we use a case study. A case study is based on a medium-scale dairy processing plant had to identify and install a geothermal energy system to replace a thermal energy system that currently uses fossil fuel in production process. So currently use fossil fuels, but we have to install a geothermal energy which replaces this. Take a background, a global dairy processing plant with a production capacity of 50,000 tons of dairy products per year. 50,000 tons uses fossil fuel for thermal energy demands, but previously conversing fuel price hike and environmental concern, plant management was charged with the full responsibility of embracing renewable energy solution. The plant needs energy at different level of 60 to 180 degree and the processes. Here are the some criteria we used geothermal energy. First one is direct use heat exchange system. Expert explanation chosen because suitable for direct use in the dairy industry for heating purposes. The decision expert thought of this system based on the fact that the plant temperature range of this was suitable for the available geothermal resource temperature. And the second criteria is binary cycle power system. Binary cycle power system. This alternative was selected. These are the alternatives based on some criteria. We discussed further criteria. This alternative was selected taking into account the necessity of the plant to consume both electricity and heat. In this, we both use electricity and heat, and the first one is used for the basin temperature. And the third is combined heat and power system. The third is the combination of first and second. The expert choose this option because the total energy use ratio was high for this option. The flexibility of the system to transfer energy use starting with electricity generation and then utilizing heat for other process was ideal for the plant multiple energy. And the last one is enhanced geothermal system. Enhanced is the geothermal system. The inclusion of this alternative was made by the expert concerning the possibility of higher temperature operation and higher power output. The expert pointed out that although the system was highly technical, it had benefits in terms of the sustainable use of resources in the long term and the possibility of expanding the system. These are the four alternatives we used. Which one is the best? And we based on the criteria. These are the criteria: initial investment cost, thermal efficiency, environmental impact, operational reliability. These four alternatives are based on these four criteria. These four criteria and step 3, these are the for B1 to G1, B2 to G2, these are the hesitants bipolar fuzzy sets. This in step we convert. There is no need to normalize the table 1 because it's all of benefit type. We use in this table all table 3 expert decision metrics based on hesitant bipolar fuzzy information are or of fuzzy type. In the formula when we in the if we given the values in the cost type, we have to complement this. But in the step, there is all of benefit type. So for z is equal to 7, we used hesitant algorithm for this. And the step 2, we convert the matrix B1, B2. In step 3, the obtained score are this. For the alternative, B1 is 0.21 and something, and for alternative B2 is 0.3, and for alternative B3 is 0.440, and the score B4 is equal to 0.48. Rank all the geothermal energy systems. B4 greater is B3 and B2 and 1 is the best. B4 is the best geothermal energy system. Out of these four alternatives, we say that operational we say that enhanced geothermal system is best to use geothermal energy instead of normal fuel energy in the dairy products plants. This is again this is the graph geothermal energy system ranking on hesitant bipolar fuzzy algorithm. This is the 0.22, 0.3, and 0. The fourth one gives the higher reliability to use this. If we use the other geometric operator, these are based on the algorithm, these are based on the arithmetic operator. If we, instead of arithmetic operator, we used geometric operator, then these are the values. And the same in for the geometric operator, these we have again the for alternative fourth is the best option to use this, and this is the Geothermal ranking system on the geometric base. And here again says that the fourth one is the best one. Is now we have to compare the method to with the other method. It is simple to determine the advantages and disadvantages of various approaches by doing a comparative analysis, which aids in decision making. In completed situation, it demonstrated how new developments overcome constraints and enhance data management for better comparison and discussion. We suppose that different theories of bipolar fuzzy sets and most supposed theories are related to different areas. Then we try to compare these two results with the proposed two results as discussed in the below table 4. These theories are these theories score values ranking. In the theory fund by BFDO, by Jana, ETL, and VTL, these are the no ranking. We say that B1, B2, B3, B4 in these alternatives give some same value, not an array order in ascending or descending. The proposed arithmetic operator and the proposed geometric operator give the values like B4 is greater than B3, and this is the from table 4. We observe that the supposed theory by Jana et al. Can handle the bipolarity nature of any information, but when any decision maker want to handle the bipolarity nature of any information with hesitancy effect, then the theory can't work. We are where the main hesitancy is the main key here we present, and our operator the hesitancy where the people are to hesitate, it is belong to the set or it is a good or a bad. Here is the hesitancy is the main because of this theory has a limited framework. The Jana ideal is the theory was a limited framework. Similarly, the Spore's theory of this same all are bipolar theories and have only brain for solving bipolar information. All are not used hesitancies. But our main motto, main USP of our manuscript is that we use the hesitancy degree. But all other are used only the bipolar. All these theories can't solve our bipolar hesitancy fuzzy information. If we give a bipolar hesitancy information, all the other previous methods can't describe this. So keeping in mind all these suggested frameworks, we try to solve our hesitancy bipolar fuzzy information and discuss the results of in table 4. We can see that in our table all these theories cannot handle hesitancy bipolar fuzzy information, so that why we can't final score values for ranking geothermal energy system. So by overall observation, we say that our proposed theory of hesitancy bipolar fuzzy Dombi operators is more general and can handle bipolarity and hesitancy at the same time. We can say that bipolarity and hesitancy at the same time. Now from we have to the conclusion, our study has a symmetrical responded to the identified research gap in selecting appropriate geothermal energy system for industrial application through an enhanced MCDM framework, multi-criteria decision framework. In this study, Dombi aggression operators have been introduced within the setting of hesitancy bipolar fuzzy sets, which effectively fills some major voids in prior methodologies that could not as address the inherent fuzziness, bipolarity, and hesitance in decision-making processes. The present hesitant bipolar fuzzy MCDM technique is proven to have excellent performance in handling uncertainty and gives a more precise evaluation of geothermal energy system. This research contributes to the theoretical development of the field by presenting a methodological approach that can be potentially generalized to our decision-making areas. The result of the case studies validation and compare analysis confirm the effectiveness of the proposed approach as compared to traditional decision-making methods. The methodology also captures the complexity of the selection process of geothermal energy systems and so on. Lastly, we can say that multi-criteria is an approach in some days. Thank you from my side. If anyone have any questions, go ahead.
Okay, thank you, Dr. Dinesh, for your insightful and inspiring presentation. Dr. Now,
Thank you, ma'am.
if you have any questions, please raise. We're all ears to have a Q&A session.
Okay. Hello, everybody. Can you hear me?
Yes, sir.
Yeah, we can hear you.
Yeah. I hope you're doing well. Thank to all of you for attending this online presentation. So I quickly go to ask some not very complicated question based on the situation. So I just mentioned that you use like about the method that you talk, and you mentioned that you talk about intuitionistic fuzzy sets. That is an extension of fuzzy sets. So usually, not only me, I think all of the people we ask, and just question like the motivation of using intuitionistic fuzzy sets. I know you use that in order to consider truth and felicity. Am I right? Like at the same time, like in fuzzy sets, we only use like a truth membership. We usually call it membership, but by using in the intuitionistic fuzzy sets, we consider truth and felicity, right? Like a membership and non-membership. So usually, based on my experience, sometimes I use like a nutrosophic fuzzy sets. That by using nutrosophic fuzzy sets, we consider truth, indeterminacy, and felicity. So now you use like an intuitionistic fuzzy sets. Am I right?
Yeah.
Or so? Uh, I just wanna consider that you didn't talk about the indeterminacy, right? Like indeterminacy is like if you consider indeterminacy like I. So my main question is your motivation of using intuitionistic fuzzy sets in this research. Can you please just shortly explain about that?
In our study, we used mainly a hesitancy bipolar fuzzy sets, not an specifically intuitive fuzzy sets. Where in the intuitive fuzzy sets, there are some consequences of hesitancy. If a person tries to fill the gap between the membership and non-membership, or the sum is one, but there is a hesitancy in the bipolar. We used mainly here this hesitancy plus bipolarity as the sum of the previous researcher, or we can say scientists used only the bipolar, but we used the hesitancy. The hesitancy is the main part here. We use for the if we concern a scenario where consider if it is a good or a bad, but where are the some people use not either to define it as a good or bad, where are the some hesitancy. So where we use only the hesitancy, not an intuistic, particular not an intuistic. Intuistic is just for the clarity of this of definition is an extension like has intuistic, now where then Pythagorean, quantic, Fermatine, and so on. Where use only the hesitancy bipolar fuzzy sets.
Yeah. So thank you. And the other things that you use MCDM, right?
Yes, sir.
You use MCDM in this, but the method, which MCDM method is used in your presentation, your paper or
Here,
whatever?
here we used mainly the combination of Vicor and Topsis.
Oh, okay. It's a combination of Wycor and
Com-
Topsis, right?
Vicor and Topsis.
Yeah. So because normally when we are using MCDM, it's because of the alternatives we have, like MCDM or MADM, like multi-criteria decision making or multi-attribute decision making. In your research, there's another like we can consider another method like when the number of alternatives are increased, and also when the number of decision maker are increased. When the number of decision maker